Okay, camera 1, camera 2, camera 3. Probably turn the scope on. That would help, wouldn't it? I always notice the screen's a little bit dusty when I start these streams, because you don't touch these screens, do you? So it always gets a little bit dusty. A little bit of focus. There we go. How to cam. Very good. Excellent. We are good to go. What's up, everybody? What's up, everyone? Hope you're doing well. Tell me about your day. What's up, Jarrett? What's up, Jordan? What's up, Mitchell? Anish, Steve. It is Friday night here in the UK. I'm busting up a live stream in the workshop. That's how I like to spend my Friday nights, guys. You know me, crazy guy, party animal in the workshop till late on a Friday. Brendan, BTR, how's it going, my guys? Just while we wait for the stream to kick in, I'm just going to sort of continue taking a peek at this. This has been bothering me a little bit for the last, probably the last hour, I think. This is girth, says explosive diarrhea. Nice, you love to see it. Well, I hope that improves in short, buddy. So we have, to start with, I'm hoping it's not going to be a very long repair, Vibe 3000.1p. This is a Chinese built full bridge mono subwoofer amplifier, and it's sort of based on the Brazilian stuff, but it's been tweaked a lot. It's sort of its own thing in its own right. It's just a very generic IRS 20957 based Class D mono 4 range. And at the moment, this thing is in the workshop because it's in Protect. Okay, it's in Protect. And we've got to figure out why it's in Protect. So I've done a little bit of digging on this already. And what it's doing, there's no dead output FETs. Okay, so on the multimeter, we check. Firstly, as you know, first thing to check, any dead output FETs. So no, we've got good readings on this FET here. Good readings on this FET here. Yep. And good readings on this FET and good readings on this FET. So no dead output FETs. So because there's no dead output FETs, we're safe to power up and see what it's doing. So what I'm going to do is show you real quick on the scope right here. If we turn it to about 20 volts divide, and I'm going to go normal trigger mode, which I don't usually do. So usually I have this in auto trigger, which basically just shows you a line all the time, and it's just showing you like a kind of live view of everything. But in normal trigger, it'll actually just kind of hold on the part of the wave that's triggered the scope to react, basically. So if we power the amplifier up, which I'm going to do now, it's coming alive, rail voltage is building. Now on this channel, which is one half of the bridge, we get this. I'll do it again. We get an attempt at Class D switching after the health check has initialized. And we just get this. So this doesn't look very healthy, does it? You can see here, this is before Class D switching initializes. This is when Class D switching attempts to initialize. And we have some pulses here. Bloody hell, what's up with the focus? Come on. There we go. We have some attempts here at switching, but we get this nonsense down here. Now if I think about that, is that low side drive or high side drive? The nonsense at the bottom here, if this amplifier is using a single positive rail, okay, I think, is it? Yeah, I think it is. Yeah, and so if this amplifier was using dual rails, then this would be centered, it would be running around 0. So the issue here is the bottom part of the waveform here, which suggests a low side drive fault, possibly. Or maybe a high side, can't remember. But either way, that's not looking good. If we compare that to the other half of the full bridge, which is on the other side, you can see that the attempt at Class D switching over there is much better. And the reason that I've got it on normal trigger mode is because if we put it onto auto, which just shows you a live feed basically, the amplifier actually protects so fast that you can't really see that on the scope screen. So if I turn it on again here, you see it tries to come on and it's already gone to protect, and we didn't see anything on the scope, and that is because it's too fast for the scope to react in live view mode. It's just like a couple of pulses. If we go over to the bad side again and let's have a look and see what we can see. Can we see anything? No, you can't see anything. It just looks like a little drop. Whereas if we put it onto normal mode, it's going to give us just the first few pulses that cause the scope to trigger. And that allows us to look at what the problem might be. As you can see here, I've zoomed out a little bit on the time divide. Yeah, that's not looking good. So that's what's causing it to protect. Now, like I said, we've got no dead output FETs. Check that already. I have also actually already replaced the drive ICs because this is a very common style problem that you'd get with a bad driver. But that hasn't helped either. So it's going to be something else. That's what we're going to have to look into at the start of tonight's stream, is what that is doing. Why is it doing this? What's different between, because essentially we've got two amplifiers, two channels, one good working side and one bad side here. So something is different about this side compared to this side, and we've just got to figure out what it is. So we can use the multimeter or the oscilloscope, etc., to check it out. So like I said, we've already checked the FETs, we've checked the drive IC, we've replaced that. It hasn't done anything. So other suspect components around the drive circuit might be these capacitors. Are pretty low quality and can go bad and cause all sorts of nonsense. Next in line of assumption, we might want to be looking at these diodes, D13, D14 here perhaps. Also by the FETs themselves, got a Zener here, D21, D22, might be bad, might be causing this. But also we can also maybe suspect this chip, which is labeled C4. Now I think this is an LM319 from memory, and that actually feeds the drive ICs with their PWM input. So if we probe the pin 3 of the 20957S, let's have a look and see what the PWM looks like going into these and see if there's any differences. So we're probing the good one at the moment here. Wait for this, I can put this back to auto level now. So the waveform actually comes alive straight away. We don't have to wait for Class D switching to initialize. The actual input waveform appears straight away. So you can see here that on this chip, which is the good one, we have PWM before Class D switching initializes of 54.5% duty cycle, 121 kilohertz. Okay. Now, if we go along to the one that's causing issues and probe that and see what that's doing, we have actually a little bit less duty cycle. You can see there, a bit more. Is it more duty? A bit. It looked like it was less on the screen, but we got 47.6% duty cycle there, which is different. It is different. It's the same frequency, but it's a different duty cycle. Now, would that be causing issues? I don't really think so. It wouldn't. I don't think it would be causing what we see on the low side drain here of the bad side. Let's just get that up on the screen again so we can see it. I'm going to zoom right out actually on the scope and just see whether we can see it from a slightly different perspective as well. Oh, helps if I press run. I had that turned off. Okay, let's do it again. There we go. So this is what we get. I'm a bit too zoomed out. Let's zoom in. There we go. So that's the issue that we're looking for. So let's just read a little bit of live chat, see how you guys are doing. What's up, Bevids? How's it going, my man? Un amplificador roto otra vez. Can't remember what that means. I haven't done Spanish in ages. Roto. I don't know what this means. Didn't learn that word in in colegio. Today I am powder coating calipers and 2-piece rotors for a R34 Nürburgring edition. That is freaking awesome, man. That sounds great. Good stuff. Yeah, Vibe is a British company, although all their stuff is designed and made overseas. Hello out here in Washington. How's it going, buddy? Hello from the Bronx. What's up, my man? Alright, so we have probed the low side drain of these FETs to get us this skanky looking waveform on the scope. So what we're going to do now is probe the gate. I want to see whether one of these gates looks bad, these gate waveforms. So we're going to probe the low side gate first, which I believe is this one. In order to get this to trigger on the scope, I think I'm going to have to go to AC couple, because the gate waveform is riding along negative rail. So I'm going to DC couple that and zoom right into 2 volts divide. Zoom in a little bit on time, and let's hit this again. See what we get. Okay, nothing because it hasn't triggered. Let's just have a play with the scope settings, see if we can get something here to trigger. Nope, not getting anything there. Maybe it's too small of a wave. Let's see, what can I do? I think I can change the trigger to the downward part of the waveform. Noise rejection off, that's fine. Trigger mode normal. AC coupled. Okay, let's try this again. Okay. That could actually mean that there's no low side drive pulses. Okay, let's move over and let's probe the good side now, which is down here. And let's see whether the scope picks up any low side drive on that one. Because if it does, then it's just that we're missing low side drive. Ah. Yeah. We did get something there. Let me zoom out a bit. So this is on the good side. Oh, there we go. Ooh, I mean, that looks incredibly high duty. 90% duty cycle isn't correct, but that definitely is something which we're not getting on the bad side. Go over to the bad side again. So here we are over the bad side. No, we don't get anything. So I actually think that we're missing low side drive on this bank. And why would... Oh no, wait, we got a little something there. Huh. Maybe it's just that the scope can't pick it up. It's very low duty. Maybe that's why the scope can't really pick it up. How can I get it to pick it up easier? Maybe zoom in a bit, actually. That might help. Reject low frequency, yeah. Noise rejection. Let's zoom in a bit and see if it can pick it up when we're zoomed in. Okay, there we go. So we are getting low side drive. Okay. It's very fast. It's very hard for the scope to trigger on. I'd love a new scope, actually, guys. I'm not gonna lie. See if we can do it. Let's see if doing a single helps. A single. There we go. Okay. The single's better. Zoom out a bit. Single trigger. Boom. Okay, yeah, that's better. So we are getting low side drive on this bad bank. Next thing I want to check is if we're getting high side drive. It's going to be a little bit more tricky. Yeah, there we go. Because high side drive, we're going to need to attach the low side drain to the scope ground reference, which means lifting the... Yeah, there we go. This is the low side drive that we're getting on the bad bank. So we are getting low side drive. That looks fine. Let's just go ahead and compare what that looks like to the good side. Yeah, okay, that's fine. So let's move over now and let's have a look at the high side drive. So I'm just going to try probing the high side drive without connecting the ground reference of my scope to low side drain, just to see if I can see any obvious differences. We're going to have to go and increase the voltage on the scope here. I'm going to keep the... I'm going to turn it back to DC couple. And let's see what we get. So this is on the good side. This is going to be a reference of what it should look like. Okay, so that is our good side, good high side drive. I'm going to put the slope back to upwards. So this is what it should look like. Oops, that was stopped on the scope. Let's try that again. This is what it should look like. There we go. And if we go over to the bad side, I mean, yeah, that doesn't look good, does it? So I think we have a high side bootstrap circuit fault. That's what it looks like to me. Yeah. This is cool because these pulses that we're getting on the high side are much less than we get on the drain of the low side, which means that it is a high side drive fault by the looks of things. Yeah, right, these are all the pulses we get on the low side drain. There's many of them, okay? Whereas on the high side gate, we only get a couple. So it's a high side drive fault. There we go, there's some diagnosis for your ass. So where is the high side drive? So it's not going to be anything related really to the input to the chip. It's going to be probably in the bootstrap circuit. So we're going to wait for the rail voltage to dissipate and put my scope back to auto level, and yeah, auto level. We've got 46 volts chilling in there at the moment, so we're just going to wait for that to dissipate. And then we're going to have to investigate the bootstrap circuit, which I believe is likely going to be, we're going to be looking for a capacitor and diode that's connected to low side drain. So it's maybe going to be this one or this one. Unlikely to be that one. It's probably going to be this one or this one, and there's going to be a diode which is probably going to be one of these two here. So that's what we are going to have to be looking at. That's going to be potentially faulty. I would say that given these capacitors, I think the most likely chance is that the capacitor's faulty, because the diodes, I have read them on the multimeter, they do read okay. Haztec says, I see a damaged diode. Do you? I have had a good look over this with my eyes and can't see anything. Which diode looks bad to you there, my friend? Probably just a bit of adhesive. D13 and 14 are both fine. 12 and 10 and 11 are fine as well. So yeah, these are all okay. This is fine. This has just got adhesive on it from the, it looks like it's a crack, but it's just adhesive from this silicon from the inductor. So yeah, not damage. But one of them could still be bad. So yeah, we'll just wait for the rail voltage to sink down a little bit, and then we'll have a probe around with the capacitors. What's your contact info? Facebook.com/bearvid. Send me a message. Hello from the Netherlands. How's it going? How is it in the Netherlands these days? Hope you're doing all right. Can you get parts for it? 2015. I've got a punch power 1000 BD, needs repair. Yeah, man. All of the parts inside are just generic electrical components, so they're not like specific to Rockford or anything like that. So yeah, of course it can be repaired, no problem. If you're in the UK, I can help you, but if you're not in the UK, then I cannot help you, I'm afraid. Okay, what are we saying about this rail voltage? We're sitting at 10 volts. Yeah, 10 volts is safe enough just to quickly short out to straight to ground. So we're just going to put a screwdriver on there and then just short that out to the ground. There we go, and it's gone. All right. So let's take our multimeter. Now, you can't really read or check or measure a capacitor in circuit with a multimeter, aside from a little trick that I learned by using continuity mode and listening to the beeps. This isn't a super reliable way of testing caps in circuit because you can be reading other parts of the board and stuff, but basically with a capacitor, when it's empty or discharged, it'll present a dead short to anything that's connected to it for a brief moment until it starts getting charged. So let's just take this capacitor here as an example. So this is an empty capacitor. So if I take my multimeter, when I test it initially, the multimeter is going to beep and then it's going to stop beeping as the capacitor charges, like so. And if we flip the capacitor around the other way, so flip the probes around, we're going to get a beep until it charges the other way, like so. Now that's obviously quite a big capacitor, so you get quite a long beep, and the smaller the cap, the shorter the duration of the beep. But what you can do is you can do this in circuit. If you take a capacitor, for example, this 47, probably 47 microfarad, one down here, we can measure it one way round, flip the probes, measure it the other way around, listen for the beep. You see you get a little tick, like that. So that shows that this capacitor is charging, and the length of the beep kind of gives us an idea of its capacity. So this is a 47 capacitor, and we've got some more 47s up here over by the bootstrap circuit. We've got this one here and this one here, so we're looking for a similar length tick on the multimeter when we measure these caps. So that one there, we've got a little tick. Yep, that one there, that's giving us the right sort of tick sounds. Now this one here is kind of covered in goop, but we can give it a go. Okay, didn't get a tick sound there. Let's try the other way around. Okay, I got quite a long beep there on that one, but that could be because there's other capacitances on the board that we're charging up at the same time. So we are getting a little tick tick there, but that doesn't necessarily mean that this capacitor is okay. It just means that there is some capacitance there somewhere that's either in parallel with this. Oh, hang on a minute, wait a minute. From probing that around, did you see that for a second there? Did you see that? Let's take a closer look at that. She ain't soldered, boys. Yeah. So my diagnosis of high side bootstrap circuit fault was correct. That is indeed a fault with the high side bootstrap. Now, as you can see, this capacitor is actually coupled to the inductor by the silicon here, which is obviously going to vibrate. And so that has just literally worked off the lead-free solder there. So yeah, that's your problem. High side drive fault. So bit of diagnosis with the oscilloscope pointed us in the direction of high side bootstrap circuit failure. So then all it took was a bit of poking around in that area to find the fault. Let's get the iron turned on and get that soldered down. And I'm also probably going to solder the other side of it, even though it's kind of difficult to get to. I'm going to have to pick away some of this adhesive here. Now this adhesive actually corrodes the solder. You can see actually it's disconnected from both pads. So yeah, it's come away from both solder pads here. It's not even connected to the board anymore. So let's just try and work away some of this adhesive so that we can solder this capacitor down. This is honestly one of the biggest causes of failure of these amplifiers from this specific build house. The silicone adhesive they're using to seat down these inductors, the fumes corrode the lead-free solder that they use. So any components, any service mount components that are covered in or very close by to this adhesive, yeah, the solder joints just corrode. It's very stupid. It doesn't need to be that way, bro. It didn't need to be that way. Should better get my iron in there. If I just drop a little bit of flux in there and then tin my ear on, I should be able to get that seated down. CB says, can I ship to you? I don't take work from overseas, man. The shipping's like 400 bucks round trip before I've even quoted you for the repair. It's not worth it. Plenty of very competent technicians over the world. There will be someone that you can ship it to in your own country that'll be able to fix it for you. Yeah, I love a bit of lead-based solder myself. Love a bit of lead. Have you ever bought flux that has... Yes, dude. Oh my god. Ethan, yes. Wait, I've got some here actually. This is the stuff of nightmares. As a repair technician, when you find flux that goes conductive when you heat it, it's going to be a bad day. It's going to cause you endless nightmares until you realize that's the problem. Which I did eventually figure out that was the problem. Repairing stuff, putting flux on driver cards, driver boards, between FETs, trying to clean off the flux but maybe not catching all of it, some flux remaining between the pads, disaster, nightmares. Yeah, the worst thing. Fortunately, this chip quick flux is not conductive in the slightest at all. So they're not using neutral cure silicone. My man here 666 knows a bit more about silicone than I do. That's interesting. Thank you, man. What's going on? Street Beats Audio. Haven't been on this channel for a hot minute. Just a few days ago, I thought of your channel. Great to see it's still thriving. It's doing okay. I wouldn't say thriving. It's hanging in there by the skin of its teeth. My channel, I started it in 2006. I'm only on 70k subs, which is sounds like it might be okay and not too bad. Hey, you got 70k subs. But this channel, man, this is an ancient channel. This is back to when YouTube like first started out. 70k is not a lot. People be hitting 50k subs in a few months with the right kind of content. I think the problem is that the work that I do is just too niche. It's not mainstream enough to gain that kind of following and that kind of viewer base. You know, you guys are watching. You're the homeboys. You're into car audio, and you're also into fixing stuff or just learning a bit about the technical side of stuff. Man, people ain't into that shit. People don't want to watch that. Or if they do want to watch it, they just want to watch like a couple of minutes of fast-paced repair, which is what I have on my TikTok. But honestly, I've been trying to brainstorm recently new ideas for my channel. Like I had the idea for Boom or Bust, which was a great idea. People loved it, but it just didn't catch the views. I do want to revisit Boom or Bust, of course. I want to revisit it and try and stick at it to see whether it picks up and gains some traction, because I think it has potential to. But what else can I do? What can I do? What do people want to see? What do you guys want to see? Well, it's no point asking you guys what you want to see, because you're here because you want to see this kind of stuff. But what do people want to see? Amp dynos, now you got Big D doing that. Basshead kind of installs reviews, you got Parker doing that. He's pretty decent at that kind of thing. Not getting too technical, keeping it real. I'm the technical guy, but not everyone really wants to see that. You'll get a handful of guys really into it that want to see the technical side, and that's cool, but that's not what's gonna make the channel grow, you know? Do TikToks make you money? No, TikToks don't make any money. Unless you're getting millions and millions of views on every TikTok and you're posting like multiple videos a day that are getting millions of views, you're not making any money. Well, maybe, I don't know, it's changed recently. They have changed the payment method, the way that the payments are calculated. And I think if you're busting out daily videos and they're getting hundreds of thousands of views, yeah, you can probably make some okay money. Just a top up to your monthly income. But not big mega money now. YouTube is still where it's at for making a living from, if you want to do that. Boris, good to be here. How's it going? All the way from Peru. I'd like to see very in-depth reviews on amplifiers. Yeah, that's the thing. Yeah, I would as well, and I'm glad that you would. But not everyone does. Like, I've got videos on my channel that are like an hour long that go into every detail about the circuit of a new amplifier. They're getting maybe, you know, sort of like 20, 30k views. Maybe if I'm lucky, they might get 50, 60 after a year or so. But that's not big views, really. It's like not bad, but I need to be hitting the hundreds of thousands. I need for every video to be getting like 200k. I mean, look at Big D Wiz. Look at Derek. We'll listen on Audio Labs. Those kind of views would be nice to be getting. So. Mitchell says exploding amps, like electro boom style. Yeah, just making amps explode for fun, I think would piss off a lot of people. Anyway, let's just take a quick look then. We've resoldered this capacitor, which we diagnosed was the problem. So let's just let's power this up again then and see whether the issue has been resolved. So low side, I think, where was the low side? Was that this one? Yeah, that's the high side with the positive rail on it. So this is the low side. So we've got low rail voltage going in just now to start with. Ta-da! There we go! Class D switching, you love to see it. Up, 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 up. Very nice. So yeah, 120 kilohertz on that bank and on that bank as well. Very good, very nice. Let's just check it's still happy at 12 volts. Yeah, 14 volts. Yeah, it's all good. We're good in the hood. That's a wrap on this one. Right, cool. That's my number one out of the way. That was just my little interim get the stream kicked off repair, so that can go now. And what we're going to be really starting off looking at tonight is I've got a whole big box. I've got actually 4 big boxes of amps come from a UK brand. And these are all just odds and ends, bits and bobs. Amps that maybe were manufacturing defects or just stuff that customer error, returns, that kind of thing. So I thought it'd be fun to go through some of those on stream with you and just see what kind of stuff breaks from factory and see what kind of stuff people do to amps and then return them. Could start a more shill-like channel. How do you mean? What do you mean shill? You could take the whistling diesel approach and acquire some extremely rare and desirable equipment and destroy it. Nah, man, I couldn't do that. Could not do that. What do you think of the Electro Voice Precision series, aka the Dynacord L series? I haven't seen them, so I don't really know. It's tricky because like I only really get strong opinions on stuff when it's come on my bench and I've actually opened it up, had a look at it, and got used to it. Whereas if stuff doesn't come on my bench, like I'm into audio, but I'm not that into audio where I will spend my evenings researching, looking on forums at like different SQ amplifiers and looking at stuff like that. Like amps are my work, so in the evening I'm just doing something else. So I don't really keep up to date with like, you know, nice equipment unless I'm in the market for it, which I'm not really at the moment. So yeah, I only really can base my opinions on what I see come into the workshop. Oh, person paid to endorse a product favorably. I see. So just take a bunch of sponsorships, get brands to send in stuff for me to review. Yeah, maybe. You know what I would actually love? I'd love for someone like HP to sponsor me a new oscilloscope. That'd be fucking sick. I could do some great stuff. Actually, I did have one channel idea the other day, which is not actually to do with car audio, but basically with my knowledge of electronics in a way, and oscilloscopes, and also a bit of an interest in computers and stuff. So basically with overclocking, right? With overclocking, you are essentially speeding up the ones and zeros. It's basically a square wave, right? It's like bits, ones and zeros in square wave form that the processor and RAM and stuff are dealing with. And when you overclock a PC, a processor, you're speeding up the frequency and you're making the little lines that make up the ones and zeros, making them shorter and shorter and shorter. And the reason that overclocks become unstable is because if the CPU can't differentiate between a 1 and a 0 distinctly enough, then it may confuse a 1 for a 0 and their corrupt data and crash. Or yeah, if it can't differentiate them, it'll just throw an error. So the whole point of overclocking is to, behind the scenes, which you don't ever see, behind the scenes is to make the frequency faster while retaining a strong, sharp differential between a 1 and a 0, the top of the waveform on the bottom of the waveform, essentially. So in order to make overclocks more stable, most of the time you pump more voltage at the thing, which makes the waveform sort of stronger, which spaces out the 1s and the 0s, makes the pulses stronger, which is why that can make your overclock more stable. But if you've ever looked at overclocking before, you'll notice that in the motherboard there are tons and tons of parameters to do with overclocking, for changing reference voltages, for changing offsets, for changing all kinds of different parameters, and it can be a bit of a guessing game really as to what they do and whether adjusting one of them is going to make your overclock more stable or less stable, because you can't see what's going on. All you can do is adjust a parameter, reboot, run a stress test, see if it's stable or not, see if it's more stable than before or less stable than before, then go back and try again. But essentially what you're doing by adjusting all those parameters is you're changing like the kind of initial voltages of the waveforms, and you're changing the kind of waveforms in the RAM side before it gets boosted up to the processor speed. You're changing all of the parameters that make up that waveform, essentially. And because you can't see what the changes that you're making are influencing what they're doing to the waveform, it's a bit of a guessing game. So my idea was to get a really fast oscilloscope. An oscilloscope, modern, fast, probably going to cost like 10 grand, that is fast enough to actually show on screen the, I don't know, 4 gigahertz waveform that the CPU is getting or dealing with, or even the slower RAM side one, and do some overclocking, push some older platforms further and further and further on regular coolers, like just a big air cooler, rather, you know, not doing anything stupid with liquid nitrogen or anything like that, just standard coolers, and getting ridiculously fast overclocks by really optimizing the overclock, using the oscilloscope to see what changes need to be made to those fine controls in the BIOS to get these ridiculous overclocks stable. That was an idea I had, and I'd start off way back at like Pentium 4, go through Core 2 Duo, go through like Xeon processors from that era, all the way up, and just kind of see what kind of crazy speeds we can get by optimizing overclocks in a way. So I thought that could be popular, but there's a lot of questions around that in my head as to whether that would even work. Would the fact that you're probing the waveform that the CPU is seeing, given that it's so sensitive, would the fact of just even probing that and having the oscilloscope probe connected, would that cause the overclock to be unstable because the probe has some capacitance and some resistance, even though it's very high? Would the scope even be able to read that fast for a frequency with good enough resolution for you to be able to see those differences? Is that even a thing? Would that even make much of a difference? So yeah, there's a lot of things that could potentially mean that doesn't work, but it's just an idea I had for a channel. Yeah, today on Beverage we're going to smoke 4 classic Soda Vega Strokers. Yeah, can you imagine the tears? I would cry, bro. Oh man, we know about that. Yeah, gas are probably using the same build house, I believe. what do we have here? Powers up, no audio. Okay. I recently saw that you repaired a P3000 RL. Haven't quite repaired yet, but I'm in the process of repairing. Although I think that might be a roadblock, might be a dead end on that one. Not because of skill or problem related, just because of the cost of parts on that. So basically, no, I although I have taken on a couple of PA amplifiers recently, I'm typically not a PA amplifier repair tech or a mains amplifier repair guy. I'm pretty much mostly 12-volt automotive stuff, but I take on the odd PA amp here and there, and I've had good success with them in the past, so but it's not something that I do on the daily. But yeah, a few people say that sounds like a cool idea. Another idea could be testing various scopes. Yeah, that's not a bad idea actually, doing like oscilloscope reviews. I would need some kind of test setup that was very, you know, that really pushed the scopes to their limit in terms of frequency, triggering, that kind of thing. Speaking of overclocking, oh thanks Anish, by the way, that's very kind of you. Speaking of overclocking, I've got this old i7 2600S CPU, non-K, low power type. The thing can overclock like crazy. I didn't think that the non-K could overclock. I thought that was the whole point of the K, was I was unlocked. Tried it using SFB and all-core turbo boost and it worked fine. Isn't the SFB overclocking? Aren't you also overclocking the motherboard, the sort of the front side bus, the frequency that all of the buses are using, like the kind of USB controller, the north. I don't know if it has North Bridge and South Bridge anymore. I'm going back to like old school days, but those kind of isn't SFB overclocking also changing the frequencies on that rather than just the multiplier on the CPU? Because that then might come into how good is this motherboard for overclocking as well as the CPU. Then got an old board that can overclock nonsense. Ah, I see what you mean. Okay. Wait till the graphene becomes commercial. Way faster. There's a couple of companies developing graphene semiconductor. Yeah, I've seen that. I've seen that, and I've also seen, what's the other one? Yeah, this is gallium nitrate, isn't it? GAN, GaNFET. You already have GaNFET devices being used in like fast chargers for like phones, laptops, devices, really tiny chargers that are like ridiculous wattage. So they're already out there in basic form, like MOSFET form. So yeah, it'd be interesting to see them become ICs and processors and stuff. That'd be really cool. And amplifiers as well. That'd be freaking sick. Yeah, man, fucking awesome. Have you finished the upgrade on the audio pipe? Yes, I have. I can finally say I have finished the audio pipe upgrade. All I need to do is just drill some holes in the heatsink to clamp the FETs down and then do some testing. But yeah, the mod is complete. Oh my god, it's Matthew! 4 GHz scopes cost upwards of 20k. Maybe we won't be doing that. Maybe, what about a used scope? Maybe like a scope that can do 4 GHz, but that's a bit outdated. Maybe like a CRT display. I don't even know if they could go that fast back in when CRTs were a thing in scopes. Yeah, maybe I can work something out with them. Yeah, it'd be a hard sell, wouldn't it, though, for them? Like, oh yeah, guys, I just started this channel with 0 subscribers. Just like freaking chuck me a 20k scope while you're at it, and I'll make some cool videos and maybe get you some exposure. It's worth a try, hey? Jimmy Broadbent reached out to, can't remember what the brands were, when he was quite small with his channel. They sent him a bunch of sim gear that was very expensive because they believed in what he was doing, and that paid off for them. So The RAM and everything gets overclocked. Yeah, that's the thing with the FSB overclocking. Yeah, is everything gets overclocked. So you not only got to worry about the CPU stability, you got the RAM, the freaking chips that are doing the USB and all the communication stuff, etc. You can get super cheap ammo scopes if the upper frequency is low, like 10 megahertz. Yeah, no, we're going for the moon, boys. We're going for like 4 or 5 gigahertz here. And also the issue is, that's the issue, guys, is that if in order to properly probe a 4, so the problem is, if we're going to be looking at a 4 gigahertz waveform on the scope, right? Yeah, maybe the scope can display a 4 gigahertz waveform, but what we are actually wanting to look at is like the rise and fall shapes and the edges of that wave. And in order to accurately kind of show on the screen like the shape and the edges of the 4 gigahertz wave, the scope actually probably needs to be like 20 gigahertz, because it's like the sample rate to show the curvature on the edge of the 4 gigahertz waveform. Do you know what I'm saying? We don't just want to see the wave on the screen. We need to see the tiny nuances and shapes of the top and bottom of the waveform. So we need a ridiculous scope that probably doesn't even exist. So the only way we could do it is probably just by looking at the the FSB, the kind of motherboard waveform frequency before it's multiplied for the processor. But I don't even know if that would be useful. You can rent them. Yeah, probably heckin' expensive. Yeah, it's definitely very expensive. Ask LTT. That's actually not a bad idea. If I had a channel or some kind of backing that I could contact them with, that they would actually like take notice of what I was saying, then yeah, maybe. But I'm just a nobody, and I have a car audio channel, but I can't really leverage my current channel to do that kind of content with, because it's got nothing to do with it. I think also for me to approach someone like LTT with that idea, I'd have to have like working proof that that concept works, which would mean I'd have to have all that equipment already. So maybe I can contact a company that has these kind of grades of scope already and say, hey, got this idea, can I like spend a day with one of your scopes? Anyway, let's turn our attention to this little thing right here. This is a nice little affordable monoblock amplifier here from a UK brand. Something nice and simple, nice and cheap and cheerful to get you some bass in your daily. Apparently it powers up but has no sound, so let's plug in some power wires and see what we got. Yeah. Another idea that I've had, which I would love to do, is, has anyone watched something like Scrapyard Wars on LTT, or something like, what's an equivalent? Maybe like Scrap Heap Challenge on the TV, or some kind of thing like that. Basically, I have had an idea where I have a video series where you got me and someone else, me and another guy, 2 guys. We go head to head, and we get maybe a week, right? We get a week's time frame, and we get a budget of, let's say, £1,000, right? And what we have to do with that £1,000 is buy a car. Okay, maybe the budget's like £2,000. We have to buy a car, cheap car, and we have to build a system in that car on that budget within a week. And then at the end of that, the 2 cars that we've built go head to head for competition. Which one's loudest, which one sounds nicest, which one has the best frequency response range, like a bunch of kind of tests, just to see which one was the best, and who could get what system in a week with a limited budget, a bit like how Scrapyard Wars works. But in order to make that happen, it would be massive overhead. Obviously, I've got to come up with the funds, like $4,000, to make that happen for the budget. And I've also got to probably hire in. I wouldn't be just doing camera work myself. I'd probably have to hire in some kind of like people to do camera work and stuff. A week's time, so I'd have to find someone else that has a week spare that doesn't go to work that can do that with me, kind of thing. You know what I mean? It is 2K is a tight budget. I don't know. You can pick up cars in the UK here, little bangers, little Euro ship boxes for like £300. So then that leaves you with 1,700 for your build. So yeah, it definitely can be done. Oh, if you need an MOT, yeah, okay, maybe £500 for your car with an MOT. Maybe use contestants' cars, that way you don't have to buy them. Yeah, maybe. Although the problem is, most people wouldn't want to just do a slapdash build in their own car. Like, if you've only got a week and a limited budget, you're going to be not caring about aesthetics. You're going to be ripping up floor things. You're going to be wiring stuff in like really janky. You know, you're going to be doing stuff that you wouldn't necessarily want to do to your actual car. What numbers on YouTube does it take to make 4K? Well, just on YouTube alone, like, yeah, you'd need like a couple of million views. But if you include a sponsor spots are many thousands of pounds. So if I got one sponsor and charged them like $5,000 for the spot, I don't know why they would pay $5,000, by the way, for a channel my size. But if I could promise them like X amount of views, maybe they would. But yeah, you know when you're watching a YouTube video and someone is sponsored by Shadow Rage Legends or fucking some VPN or something, that company have paid them probably thousands of pounds. I know for a fact that certain channels in the past were paid $20,000 for a sponsor spot. So yeah, there's money to be made there. Okay, why do we have infinite current draw? Probably because these are touching. I haven't wired it backwards, have I? No, I don't think so. There we go. Oh, wait, we have 0.4 amps of current draw? Ah, I see the problem. Well, this isn't just a no audio. Let's take a look at the power supply section here. We have some cooked gate resistors there, my friend. So yeah, I just powered the supply on, noticed 0.4 amps and thought, uh-oh, power supply. Yeah, looks like we have dead power supply FETs at least. It's just going to be a full rebuild. Let's take the multimeter right here quick and let's see what the output FET's saying. I suspect we've got some dead output FETs because that's what usually happens with these. It's a full rebuild. Yep, dead outputs, full rebuild. Let's just do it. Let's just do this a full rebuild. It's cheap as chips parts, and we can do some chats while we're at it. So yeah, you guys are liking the idea of the kind of Scrapyard challenge. I love that idea as well. I think it would be so much fun. Just got to try and work out how to make it affordable and you know, how to actually make it happen. Because at least for the first episode, with it being me and someone else, I'd need to find somebody else that has the time and availability to do something like that, that doesn't live a million miles away. It's the kind of thing I could do with Slimewave 02 actually. Some of you guys might have seen Slimewave 02. He's got a fantastic TikTok and YouTube channel. Lots of audio stuff, really good camera work. And it's the sort of thing I could probably do with him. Because I feel like he might be able to have the time to do that. But yeah, we just need to get the money from a sponsor or something to make that happen. Go scrap cars with no MOT, just purely for the audio. That would be a great idea. The problem is, when you've got scrap cars with no MOT or non-runners, you've got to have a bit of private land, a bit of space to do it on, which I personally don't have. I have a friend nearby that does have private land, a unit to work with, you know, on the car in, but he uses that space for his business. So for me to take up a week's worth of space for that would not be ideal. I don't think that would work. Try contacting a few lower brands and see if they'll supply gear. Yeah, the supplied gear maybe would be cool, but I think part of the fun of that Scrapy challenge would be what random gear can we find on Facebook Marketplace. That would be part of the fun. Would be like, what stuff can we find? So if the gear is just supplied, that kind of takes part of the fun out of it, I think. Rob, I'm good, thanks, my friend. How are you? Nah, you get some good stuff on Facebook Marketplace over here. You definitely get some interesting audio stuff, and that's the thing. Like, if you've only got a week to do it and a limited budget, I see like the kind of equipment being like mix and match, like running a freaking Sony X-Plod in a ported box alongside a JL Audio W0 on a different amp, like, you know, just kind of chucking literally as much random stuff as you can find in there, because every 0.5 of a dB is going to matter. And so it'd be a case of using random gear that's maybe not great or mismatched gear, but then using our knowledge and skill to make them work with each other correctly, setting all of the amplifiers correctly and setting the phases so that the subs don't sort of cancel each other. So it'd be on the surface really janky and mismatched and, like, you know, junkyard kind of vibes, but it would be put together with some knowledge to get the absolute best out of whatever random stuff we found is. And I think that's where the fun is. It's like a little bit of jank, a little bit of knowledge, throw that together in the soup, and that makes for a bit of entertainment. And it could also do fun stuff like, you know, obviously my advantage would be my knowledge in electronics and amplifiers. So if I picked up an amp off Facebook Marketplace, I could like pull it apart on the bench and like add some more turns to the secondary and pull some more power out of it. You know what I'm saying? So that could be fun. Just like, you know, oh yeah, this amp, whatever, it makes like 1,000 watts at 1 ohm. Like, you know, if I'm going to beat sine wave in this challenge, I'm going to need a bit more power than that, but I'm limited on my budget. So let's just wind some more turns on the secondary. The amp only has to last for a couple of burps, so it's fine. You know, that kind of vibe. Yeah, man, you see all kinds of stuff. Matthew, yeah, I've seen that. 2 different subs in the same enclosure. Yeah, all kinds of stuff. But that's the sort of thing that you'd probably be buying in a challenge like that. You'd be buying the mismatched subs in the sealed enclosure, and then you'd be like maybe building a ported one for each or something, or right, let's get these 640Ns out of here. How about pimp my ride type thing just for bass? Well, like where we get someone in that wants bass in their car and video and vlog the whole process, the build process of getting them something decent. The whole thing with Pimp My Ride is that the guy who owns the car doesn't pay for it. It's just kind of stuff that's like given and put in for free. So that could work if it was all sponsored. Actually, that's not a bad idea. If all of the gear was sponsored, then that kind of thing would work. Man gets a free audio build by the sponsor, and we get to make a video series on it. The thing is with Pimp My Ride though, is that it's all that thing was just very, very outlandish. The whole reason that was popular was it was like very wild and outlandish, like hot tubs and freaking games consoles and like bars and stuff, all ridiculous things in people's cars. If I was doing audio builds for people, firstly, I'm not a fabricator or an installer, so I personally wouldn't really be doing any of that crazy like fabrication stuff. It would just be more like sensible builds, which I don't really know if that would bring the big enough audience. Pimp My Ride was pretty scripted and apparently took months on end for people to get their stuff back. Really? Well, it doesn't surprise me. It's all TV like that, isn't it? So. So the only reason 2 subs in a sealed enclosure would be quieter than just 1 is if they're not on enough power, because yeah, like one single sub in a larger sealed box may actually be louder than 2 in the same box if the power's not there. That is definitely a potential. Or if the 2 subs are phased, the phase of each of the subs is so off that they're kind of cancelling, but chances are the phase is going to be in phase enough for it to be additive to some extent. Do you want to know what I've noticed, guys, that I'm really cross about and I'm really annoyed about? You see this camera that you're looking at right here? Okay. This is my JVC camera. It's using a HDMI with a capture card, right? And I wanted to make this camera be as high quality as possible, right? So for the longest time, I've been using this capture card, which is just some Chinese piece of like cheap capture card, right? Single HDMI input. It tops out at 1080i. It's not even 1080p. But that's the one I've been using for years, and it just works. It just works, and the images always look fine. I have to add some de-interlacing, but it just works. But I wanted to up the quality a bit of it, thinking I'd get 1080p, maybe it'd look better. So I got myself, I think it's the Elgato something 60 HD or whatever it is. It's a PCI capture card. Really high quality, really high specs, really well reviewed, full 1080, 60 frames a second, 1080p. But it just doesn't look smooth. I've currently got it set to 30 FPS. Okay, and the reason I've got it set to 30 FPS is because when I set it to 60, it actually looks worse. I'm going to set it to 60 right now. This is set to 60. It's smoother. But do you know what I mean? It's like jerky. Compare that to my hat cam, right? My hat cam is 60. And that is like really proper. That's proper 60 smooth. That's lovely. Yeah? But that's not 60 FPS, is it, guys? You can just see it's not. And this cheap capture card looked so much better motion-wise than this expensive one. It's really frustrating. Why? I'm going to change it back to 30 FPS. So this is 30. So yeah, you can see it's definitely 30. Looks like a slideshow. And this is 60. It's smoother, but it's like kind of jerky. Do you know what I mean? I'm not using the HD60 USB card yet, Matthew. I do want to integrate it and use it for my microscope here. I need to add some more USB slots to the PC because it is struggling a bit. So yeah, I do want to use it, but I haven't yet. But the capture card is basically the same as what you've given me there, but faster version because it's PCI and it has slightly better specs. Yeah, that's fair enough, Dr. Diner. Maybe it's that. Maybe it's something to do with that. Yeah. Anyway, so yeah, we've got all the FETs out of this. Let's just clear the holes out. This will be a nice easy repair, but you can see that when it blows, it fuses the trace that leads up to the FET. This is really common. This is one of the reasons why it's important not to do a top board repair if you can avoid it, because you miss stuff like this. If you just remove and replace parts from the top, you can miss stuff like this. So it's only worth doing a top board repair if you're not replacing, like if the failure hasn't been high current draw failure and you're just replacing surface mount parts, you can do a top board. Or if you know that the PCB is like definitely thick enough that this will never happen, you can maybe get away with a top board. But for the most part, pull the board. Muy bien. My camera's pointed very downwards today. Let's get that up a little bit. It's a bit better. So now we just got to flip this around and remove the gate resistors, because these are all open, as you can see. So we're going to kill two birds with one stone and remove them with the main iron, which will also tin them at the same time. The fact that the gate resistors look like this also means that the drive transistors probably look a bit like that as well. So we're going to investigate the drive transistors in a sec. And this adhesive here, when you heat it up, it releases cyanide and cancer, so just try and avoid heating it if you can. There we go. So the drivers are, for this one, probably going to be over here. Let's just confirm. So probe the gate pad here, follow the trace. It's going to go under the board, Probably here. There we go. Oh, it actually goes down here. Okay. Yep, they're shorted. As you can see, we've got continuity on all 3 of those pins. Q66. So, yep, they're buggered. We've got L6 and M6. Alright, let's swap those out. Boomer Bust was awesome. Gutted there wasn't the views to support it. Maybe there will be one day. Maybe season 2 will pick up a bit better. I am planning season 2, so we'll see. Might be a little winter project for me. Things usually quieten down a bit on the repair side in the winter, so. Powered it up and it popped the 20 amp fuse, says Scott. Initial testing found one of the FETs driving the inductor in the power supply stage to be short. You could probably figure out a replacement MOSFET to put there, my friend. Dude, if you do a season 2, get a hold of some of the 3D printing channels. Okay, I'll give it a go. What would you recommend I say to them? Like, better 3D printer? I think my Ender 5 does an alright job. Doesn't need to be super fine details for the boom or bust, but how's it going, Lowry? Today you were late. Yeah, you were late. Usually you're number 1. A bit late today. Yeah, look at how framey that looks. Scott says, it's the first time I made it while you're live. How's it going? Hope things are going okay in Texas for you, my friend. Oh, filament sponsors, printer sponsors, something like that. Yeah, not a bad idea actually. Might hit them up. Hot, yeah. This is just this amplifier is just a generic Chinese, cheap and cheerful little mono subwoofer amp. It's fine. Does the job. What do you think of the heated tweezers? I have tried them. I suspect you can get some good quality ones that work really well, but I just found I had better experience just using a regular soldering iron or hot air. Alright, now which one of you is PNP and which one of you is NPN? Oh. Right, you're NPN and you're NPN. So NPN on the bottom, NPN on the bottom, well, it's kind of the top really. So 65 and 66 are the NPN. Nice. What parts have I got to put in there? D drive. Got some. I might just put 2x2t. That works every time. Nice and easy. I was jealous of your big soldering gun, so I bought a huge one, like 2 pounds of metal. And I heat it over my oven flame. It stays hot for like an hour. Bloody hell. Is that really needed? Does it, I assume it doesn't have a heat... Oh. I assume it doesn't have a heating element of its own. You have to heat it externally. That's pretty crazy. So apparently my webcam that I'm using for this camera, which is a DJI Osmo, it uses more battery than it charges when you're being used in webcam mode. So it's currently on 10% battery. That's either the USB-C cable that I've got is too long and not thick enough wire inside, or my PC just can't supply the current to charge it enough while it's being used. That's weird though, isn't it? It's using more power than the USB can supply. Maybe I'll try turning the display brightness down. Can I do that easily? How do I do that? Settings. Can't go into the settings. Maybe brightness here. Ah, yeah, there we go. Yeah, I'll put the brightness at 0. That should help. Okay. T goes there. Solder that in place first. I'm going to need to keep a note of these amps that I'm repairing, because otherwise I'm going to forget what was wrong with each one of them. I've got 4 massive boxes full of amps like this that we're going to be going through. I'm going to have to remember the faults on each of them so I can price them correctly. Okay, there's all new drive transistors, so we're going to need to do the same with the gate resistors over this side. Just drop some 10s in there, I think. There we go, there's some 10s. 1, 2, 3, 4. How's it going, Joseph? Yeah, so with Boom or Bust, yeah, I'd love to expand the audience a bit to the 3D printing crowd. Some of you may have seen a series on YouTube called The Fan Showdown that a guy, I think it's called Major Hardware, does. And his videos, basically that's the inspiration for Boom or Bust a little bit. So his videos of the Fan Showdown get like monstrous views, and that's the kind of views that I would need or would like to get really for Boom or Bust to really work and be viable. So I just need to try and get that audience on board. Alright, sick. So gates, drivers all replaced. So if we take the oscilloscope probe and probe one of the gates, we should get some gate drive PWM on this pad right here, for example. Helps if I connect my remote wire. Oh. 0.6 amps, that's a bit much for no effects. What's going on? What have I done wrong? What have I done wrong? Okay. We are not building voltage for the NPN driver over here. The NPN driver needs about 12 volts on it, and we're not getting 12 volts, we're getting 1.6, so that also probably means that the TL494 isn't getting 12 volts. Let's just have a check on this pin right here. Nope. Okay, so we've got an issue with whatever transistor supplies TL494 and the NPNs with VCC. Okay, so that is going to be so it's that one there. 71. That's for a fan that's not fitted. What transistor generates that? Could be one of these around here somewhere. Usually it's around here somewhere. Alright, pin 12 of the TL494. Okay, here we go. We've got, oops. Pin 12 of the 494, got this one right here, this one right here. This one right here, this one right here. So it's probably going to be one of these two. So if it's going to be one of those two, then it's going to have 12 volts from the power terminal on it somewhere here. There we go. Oh wait, no, we're just charging. That's probably ground. That one there, Q69, has 12 volts from the power terminal. Okay, let's just power up again. Let's see which one of these is getting hot, because that's probably going to tell us a bit more about it. Okay, both of these get really hot, as you can see. They evaporate immediately. So I think just replace both of those and see what happens. They are both M6, so M6 I think is the NPN, so 2X. Yes, I do have an infrared camera, but sometimes it's just easier to spray some isopropyl, especially because this infrared camera, the resolution isn't that great, so it would be quite tricky to pinpoint these tiny little transistors. Back to the scrapyard thing, why not see who can make the loudest system using only cheap, i.e. Chinese overrated stuff, say under 500 quid for the whole system, just bass, no SQ or mids. Yeah, that sort of thing, that's sort of the idea with the scrapyard thing. Obviously I can go down on the budget and just have it be subs, but at the end of the day, I kind of want it to play music as well, like, you know, I want it to be listenable and enjoyable. Bass is just bass, you know what I mean? I would definitely want to try and do a whole system for some amount of money. You could even do a whole system for 500, and it wouldn't have to be like massive bass, maybe just like a single 12 or something. How much is your P2 Pro thermal cam, Electric World? Actually, you know what? Just before I do that, let me just check the resistance from pin 12 of the TL494 to ground, because if there's a short somewhere else, 470 on the multimeter, and nah, there's no short there, so it's got to be those transistors, surely. Unless like maybe have I like made a solder bridge maybe? Maybe I should just check, sanity check, because I just want to make sure I haven't like done something stupid here and made like a solder bridge. Okay, no, not that. No, no solder bridge or anything like that on there. And you know what it is, guys? Somehow I've managed to put the drivers in backwards. I haven't noticed that. Hey. I'm sure I said that the top ones there were NPN, but no, the other way around. Fortunately, it should take less than 60 seconds just to swap them around, and because we had super high current limiting on, no damage will be done. What's your thoughts on fourth orders? I'm not a big fan of fourths, but I have heard some really nice sounding fourths, so I think it just depends on the driver. To me, a fourth order is basically a sealed box response with a big bump on the higher frequencies, which is not really what I'm into. I want the bump to be on the lows, so I prefer sixths because you can get that massive energy out of the woofer on the lower frequencies and on the highs, but they sound like ass because the group delay is so large. So yeah, I'm not a massive fourth fan, but they can be super musical though. Let's try that again. So we should be able to do this now and have, there we go, 0.2, that's better. That's better, there we go. Just had the drivers in backwards, my bad, whoops. No, never mind. Decent PWM there, 1, 2. Yep, it's all looking healthy. Alright, nice stuff. So let's just turn that off. We're not building any rail voltage, of course, there's no power supply FETs. Let's just do a quick continuity check on the output side drivers, which are these two X2Ts over on this side of the board here. Just make sure we've got no dead shorts. The drivers often die on the output side, but it's like 50-50 as to whether they survive or not. So I'm just seeing whether there's any shorts. So none over there. And this side. That looks a little darker, that transistor there, but it might be alright. We shall see. As soon as we get a bit of rail voltage, we shall see. Any dead gate resistors on the output side, that's always a good sign as to whether you're going to have dead drivers. So we've got, that's alright, that's alright, that's okay, and that's okay. So chances are there wasn't really much energy making its way back to the drive circuit of the output side, so we're probably fine. So let's load up some power supply FETs. If I can even get them in the holes. They're not get sucked enough. Oh man, these holes are so small. Alright, how much leg have we got on them? Quite a bit by the looks of it. On the other side. Dropping some 3205s in place of the factory 65NF06. Not for any specific reason other than I got a bunch of 35s, 3205s really cheap from a reputable supplier, so I have a load of them in stock, might as well use them. 1, 2, 3, 4 gates. 1, 2, 3, and for the 4th drain I'm just going to bend the leg down like this because the trace fused, so that leg is just going to bridge over the fuse in the trace, like so. And then drain time. Oh no, sorry, source time. 1, 2, 3, 4. Very good. Little bit of isopropyl, little bit of wire brush. 60 frames a second, my ass. Looks like I was just like teleporting from one side to the other. Let's have a look and see what it should look like. That's what it should look like. Alright, so now time to see whether the output drivers survived, and to do that we are going to power the board up, build some rail voltage, and probe the... On these boards you actually do get low side and high side gate drive. The reason you get that is because the high side for these amps isn't bootstrapped. It actually has its own 5-volt supply regulator sort of thing, so even when there's no low side drain switching, the high side always has a supply, so you always get some drive waves there. I think it is bootstrapped, but the way the circuit is designed, there's always a bit of 5 volts there ready to go. This is an interesting way of doing it, but never mind. So let's probe, I don't know, one of these. Let's work out which is low side drain first. Okay, there we go. As you can see, we got the high side drive on the disc-op, which always looks a little bit wobbly like that. That's your high side. That's normal. That's not a problem. Don't panic. If your drive looks like this on the high side on these boards, no problem. No panic. The low side should, however, look nice and sharp, like this. Very good. Got 4.9 volts RMS on the low side drive, but only 3.8 on the high side. I can't remember from memory whether the amplitude of the low side and high side drain should be the same, or whether the high side is always a little bit lower like that. So I guess we'll fit some vets and fuck around and find out. Because if it works, then that's correct. If it causes issues and nonsense, it means that the high side drive is weak. I don't think these boards have pull down resistors either on the rail caps. So I think, oh no, this one does. We are sinking down nicely. The negative rail has already disappeared. We've just got a bit of positive rail left to go. Let's just short that out real quick. There we go. Okay, some 640 end time. 640 ends. ¿Dónde está? Está aquí. Muy bien. Right. Let's just find some that are the same batch. HCGT. We only need 4 for this amp. There we go, that'll do. How are you, Sam? It's difficult to catch you live in East America. Yeah, the time difference do be like that. So, but I'm good. I'm doing all right. How are you? North America. Do you mean Canada? No, I'm joking. I'm joking. This is a really frustrating board to work on because the vias, or the holes for these FETs, they're like just big enough. So if there's even like a nanomillimeter of solder left in the via, it's really hard to push the FETs through. Really annoying. You've definitely seen this board or this circuit layout hundreds of times before. If you work on amps or if you're into car audio and watching amp videos, you will have seen this circuit like hundreds of times from lots of different brands. Mike says I've got a fourth right now, tuned to 40 Hertz, but it hits 28 like a boss. So that'll be because you don't have any unloading on the lows because you have a sealed chamber behind the driver. Also, you have cabin gain at those low frequencies as well, especially with the windows open. But let me tell you, it would hit 28 even more like a boss if it was a sixth order. I don't know why the views were so low. I think maybe it was just like maybe I wasn't really doing the thumbnails right or the titles right, or maybe it just needed the algorithm to pick it up. But another thing that I also think is I think that my channel, it's not shadow banned, but I think my channel might be kind of internally marked by the algorithm as like a kind of old ass channel that doesn't really get the kind of, you know, views. So I don't think the algorithm is really super interested in pushing my channel onto new viewers because it's really old. It's grown so slowly over the years. So I honestly think that there's actually a bit of background going on with my channel and the discoverability is quite low. So I wonder whether it would actually be more beneficial for me to start up a new channel for Boom or Bust. It would be really sucky because it means I wouldn't make any money on the videos until I got the required viewership. You know, I'd have to like get monetized again, which means that the first, you know, Boom or Bust episodes would be kind of whack. But alternatively, maybe I could make a new channel called Boom or Bust and just release the series 1 episodes again. And that'd be really annoying for all of you guys who have already seen it. But maybe that would kind of trick the algorithm into pushing those videos to new people and gaining some traction that way. Because then it doesn't really matter if I don't make any money on them because I've already made the money on them that I'm going to make on my main channel. So yo, what's going on, Donnell, my man? Good to see you here, bro. How's your day been? All right, let's see what we're saying then. Was that high side drive enough, or is it too low and is going to be new drivers for the output side time? Check on the solder bridges. Yeah, looking good there. Looking good there. All right, let's check the low side drain. Power it up, see what it does. looks good. We've got 0.5 amps worth of current draw there. Nice Class D switching on the scope. Let's just check that low side gate and compare it to the high side. Okay, that is actually a strong looking low side gate for this style of circuit. Usually they look really bad. And on the high side, yeah, looks good. Let's just pump up the voltage a little bit. 12, 13, 14. Yeah, looking good. Very nice. Easy fix. I think the algorithm should reward you that you kept viewing for so long. One of the algorithm rewards watch time and click-through rate, stuff like that. So yeah, although I've got a little community here of people that have been watching me for a long time, the algorithm is like, no man, that's not what makes money. Glad to finally catch you live. Yeah, I'm glad to have you here as well, my man. We've been chatting a little bit actually about what we were talking about earlier, about ideas, things to do with videos, etc. We've been bouncing around a few ideas. That's true, yeah. A fourth definitely will probably sound better to a ported enclosure, because for the most part you're going to get the low group delay from a sealed enclosure. But yeah. I do have ads turned on for this stream, guys. It should be feeding you an advert every 24 minutes, roughly there or thereabouts. That's what I have asked it to do. Whether it's doing that or not, I don't know. The rare viewer request. Where's the ads? Give me an ad. That's what I love about this community that watches my videos, because you guys get it. You don't mind watching an advert for me, as long as if that means that I get a little bit of money for this stream. The rare viewer request. Give me an ad. You know, one thing that actually works, guys, is if you watch my stream in multiple tabs. Yeah, so if you open this stream in multiple tabs, it actually works. It actually causes more views, and also when the ads play, it makes me more money. The more tabs you have of my stream open. The Spiffing Brit proved that on a stream that he did. Ethan says, in my latest repair on a Class D monoblock amp, it had one shorted rectifier. First time I've worked on an amp with that issue. Shorted rectifiers are extremely rare. I would say I get maybe a small handful of shorted rectifiers in an entire year. It's very, very uncommon. Rectifiers are pretty rugged devices. Just out of interest, what amplifier make and model was it? Because I see more shorted rectifiers on these Chinese full bridge clones, because partly because they use like 2 rectifiers for 3000 watts, so the rectifiers are stressed more, so when the output FETs die, there's like more chance of them failing, but also I think there's been a bad batch of rectifiers going around. Taramps got stung by a bad batch of rectifiers that they had fitted to a bunch of their Big Boss 8s and potentially some other models as well. And it's very unfortunate, because nothing wrong that Taramps has done. Their circuit design is solid, but they just got stung with some dodgy rectifiers. You get anti-suicide ads on Steam. What the heck? It's wild. Oh no, sorry, not on Steam. On Twitch. Not on Steam. I see shortage rectifiers all the time. JL 1001s. Oh yes, I have seen some shortage rectifiers on the JL audios actually. Yeah, that's another brand that I've seen it occur on. But it's not very common for me, and a lot of other technicians don't really see it that often, to be fair. Yeah, I'm not suicidal, but if you keep showing me these ads, I might be. Like a guy kills himself from repetitive what's it? Fucking harassment from the adverts. What a twist. Also, apparently me saying these words, like the K word and the S word, that I just said then, probably aren't really helping my channel, because the algorithm's going to be like, oh, nope. Ah, you bugger thing. Get out now. There, that's where you were before. The Bevid's POV cam. So apparently my internet connection can only handle 35 concurrent 1080p copies of your stream. Bust them down to like 240p, my man. The quality doesn't matter. Shall we see, after me saying that, there's been a spike in my concurrent viewership. Let's see. Where are we now? We are here. And unfortunately the graph is too fine. Wait, how did I have wait, what? Okay, 13 viewers. Yeah, for some reason it's like the graph is going all the way back to 6 AM, which is not what I want to see. Okay, here we go. That would dropped a lot of viewers actually recently. So I'm only at 56. Heck, that is like really bad. I used to stream and get like 100 views, people watching at any time. I guess that's what happens when you don't stream for a while. All right, fixed. Next one. What do we have here? This is a Class AB 4 channel. Let's do something a bit more interesting. Let's have a look at this. This is DSP 6/10. So this is a DSP. Okay. What's the problem with this? What do we get in the box? We get a DSP. We have 10 output channels, optical input, controller, mode button, only one in, like two inputs there. we've got quite a few high voltage inputs, but only a pair of low voltage inputs. Okay. We have the controller, which looks like this. We have an SD card slot in the controller. This drives me nuts. I hate it when you have a rotary encoder like this with a freaking marker. That makes no sense. That just screams cheap to me. No, don't use a knob that has a marker if it's a rotary encoder, because it doesn't make sense. You know what I mean? That just winds me up. But anyway, yeah, cool little screen. Push button on the encoder here. USB socket as well. Okay, cool. Let's get the power wire thing here. Okay, power, 12 volts, ground, and remote. Am I missing a wire here? I am missing a wire. I'm missing this connector. Well, that's annoying. That's got the remote on it. And 12 volt and ground as well for power. Why has it got dual? Why has it got two power connectors? It's got power over this side and power over this side. Okay, well, I guess I can flip this switch maybe to make it be sense instead of wired, so that it comes on without needing the remote connected. Or I could maybe shove a wire in there. Let's see what I got. See what I got. Got something to shove in there. There we go. I could shove that in. That'll do the job. Let's flip that back to wired. Does this have an internal amp, or is this just a DSP? It says high output, so it looks like there might be an amp in there. Let's take a look inside. Let's see what we got going on in this thing. Maybe there's a separate power connector for the amp and a separate power connector for the DSP. Oh yes, there's your internal amplifier. That's just going to be like your kind of standard head unit amp. So yeah, there's your internal amplifier, 6 channels. There's your antenna for Bluetooth or Wi-Fi or something, wireless. Actually, looks like we might have some channels over here, some channels over here. We've got two amplifiers there, 2 amplifier ICs. There's some burning going on over here. Looks like some burn marks. Yeah, this is all crusty. What used to be there? This is marked as 100-6V. A Zener diode, perhaps? Or a fuse? Yeah, I mean, this is so cooked that I have no idea what that component used to be. But let's have a look on the rest of the board and see if we can find any other markings, like silkscreen markings that look similar. 100-6V. Uh-oh. There's some more visual damage over here. This op amp. The lighting's really bad this evening for this camera. This op amp has a hole in it. Okay. I assume that's an op amp. It might not be. We'll find out soon enough when we Google the marking. So we have something with a hole in it there. We have something potentially over here with a hole in it. Yep, this has got a hole in it as well. Is that D1 or D11? D11. So we've got D11 toasted. This probably op amp, maybe something toasted. This toasted, whatever that is. So with many random failures like this, a schematic would be useful at this point, but we can work our way backwards. So let's start off with the most sort of Googleable device, which is going to be this. So what are the markings on this? And for this repair, guys, because this is quite small stuff, I'm actually going to swap the cameras around and plug the HDMI into my microscope here, which is going to be kind of cool because that's going to look a lot better. So you guys can actually see what we're doing, see what's going on. So let's just move my microscope over. There we go. You can kind of see it through the hat cam actually, rather than me plugging it into the HDMI. I wonder if just looking at it through the hat cam and getting my perspective of it is going to be good enough. Right, let's get the light on it. And then let's just focus in. I mean, yeah, you can kind of see that well enough, can't you? So right, the only markings I can see on this diode is L4. So it might have had something before the L that's now burnt away. But yeah, we might be able to find another diode on the board that's also ending in L4, which means it'll be the same model of diode that's used. ZF5, that's a transistor. That's a transistor. Let's flip this round to get a view on the other side. Let's remove that for a minute. I don't think there's any more of those diodes that have that marking on them that I can see anywhere. But what I have found is another device that has that same silk screen after it. So if we take a look at the little amplifier module here, if I can look at the fuse, if I can get the scope on that, there we go. So this is probably the fuse that's in line with the rail that goes to this little amplifier IC here on the heatsink. As you can see, it's marked with F3, but then it's also marked with 100-6, and then that's probably 6V. We've got probably another one over here, F2, 106V. So yeah, basically that means that whatever this burnt device over here is, that's a fuse. It used to be a fuse. Okay, that's good. Good to know. Now that fuse looks like, was that feeding part of this chip, or was that feeding something else? we can find out for sure. But let's just turn our attention to this little chip over here. Hopefully I can get a view of that under the microscope. So that there is burnt to a crisp. Let's take a look at another one, see if we can get a reading off of it. It's either an MS4344 or whatever it is underneath that. So let's Google MS4344. Let's see what we get. Oh, it's a digital to analog converter. Well, that's just downloading a 0-byte file. Nice. Right, it's a DAC. By the looks of it. Yeah, 1, 2, 3, 4, 5 pins on each side. Chinesium DAC. So we have VCC. Is that going to be VDD, pin 9? So let's just see, where does pin 9 connect to on the board? And that will then tell us a bit more about what caused the failure initially. So pin 9 is going to be this second to last one on the end here. I assume these are all going to be in parallel with each other, with the others. Yep. Okay. So probe pin 9, and where does that come from? We've got a capacitor here, and then let's go over here and see whether it goes to any of these places where there's burnt stuff. So we've got a low resistance to this burnt diode, whatever this is. This fuse that's burnt open. Again, lowish resistance there. Let's maybe find ground. Let's see if we've got a low resistance to ground. G&D, ground. So yeah, we've got 187 ohms to ground from that VDD. So yeah, stuff is shorted. What's generating that though? Looks like it might be this large sort of transistor looking boy, U3, in the middle of the board here. If I can just kind of get my camera focus. So yeah, this guy right here, looks like that is generating that voltage. We have 168 ohms between legs 1 and 3. And also 1 and 3 and 2 and 3, and we have a dead short between 1 and 2. Okay, so that's dead as well. This fuse, where does that connect to? 12 volts. Okay, so it's on. We have ground on one side. Yeah, this is a fuse that has ground on one side, and on the other side it has, well, yeah, there's a 27 ohm resistance across this apparently. So is it a ground trace? Why would the ground trace be fused? Interesting. I wonder if it's some kind of reverse polarity protection, something or other. Now this diode down here that's burnt out, does that have any connection to anything? We've got some ground on one side. Yeah, you know what? This is actually giving all the signs of a reverse polarity event, because we've got burnt stuff randomly on the board, that has a connection to ground. Like, there's just a bunch of random crap that's burnt out that has a direct connection to ground. So that would kind of make sense if there was a reverse polarity event here. So let's just see whether any of these digital to analog converters have ground on any of their pins. Yeah, of course they do. Yeah. So this is a this is a reverse polarity event on a DSP. That's going to have killed fucking everything. This is probably going to be not worth really, like, everything's going to be dead. Like, every single one of those DACs probably is dead. Probably the DSP chip itself is dead, wherever that is. This guy right here, maybe. The amp modules, maybe, are also dead. It looks like these fuses in line with the amp modules have got hot. I mean, 3 ohms on that is a bit high for a fuse. But maybe that's correct, I don't know. This is fucked. This is KO'd. Just out of interest and for entertainment purposes, what I'm going to do is I'm actually going to just start pulling off some of the dead parts, right? The obviously burned and shorted parts. I'm going to see how far back we get, and see if some of the short to grounds go away and stuff like that. I'm going to pull this transistor as well. We'll try and clean up wherever that fuse is over there. Bridge that over just for fun as well at the moment, maybe. Yeah, let's just start pulling stuff. Head units aren't really my thing. It might be vibration damage, could be a cracked solder joint somewhere. I would take it out of the vehicle, get it on the bench with a known working power supply and known, obviously, good wires, and just to confirm that the issue is present also away from the vehicle. And if it is, then start giving it a bash, knock around. If you notice that, oh, after whacking it on the side, it then comes on, then you know that you're looking at a physical failure of some connection point somewhere. I'm using some Chip Quick Flux, best stuff that I've ever bought. That. Yeah, no reverse polarity protection on this. This is a really budget level piece of kit, so I doubt that they've really put too much thought into that. This DSP could definitely have had just a freaking diode in line with the 12 volt. Although now maybe it couldn't actually because it's got amplifiers built in. I was going to say a regular DSP requires such little current that you could just drop a diode in line with the 12 volts, drop a few millivolts, no worries, and call it a day. Wow, Joseph, you've got a lot of dead base phase amps there, my friend. That's going to be a nice healthy repair bill on all those. Alright, so I've removed 3 pieces of obviously burned evidence. I'm just going to go short circuit hunting with the multimeter now. Once I bridge over this fuse for a sec. You know what, it might actually be worth pulling the circuit board out and looking for blown traces on the underneath. Like, I don't know if there would be any blown traces. I mean, there might be. Who knows what we might find underneath. There's not any components themselves on the underside of this board, I don't think. But we might find more evidence of like stuff burning perhaps, who knows. Yeah, so just for diagnosis purposes, I'm just literally going to drop a jumper wire across that fuse there. We've got a current limited bench supply, so yeah, it doesn't really matter. I just want to get that connected so I can make some tests with the multimeter. There we go, that will do for now. Alright, so let's once again check from the VDD supply of this, which was pin 9, I think it was. That was going to here. So let's check to see whether we have any continuity to ground anywhere. We have 176 across here. One way. Ah, that's like a diode. That's like a 170 something across there. Okay. What do we have to ground? That is ground, isn't it? There. So we have something. Okay, I might actually inject a little bit of voltage there and see if there's any current draw. Ah, we have a short across this cap. So that's either the cap or something on the board. We have a short across this cap as well. Well, this cap is going to be buffering the supply voltage for this chip. So what is this chip and what is its VCC? Does it share VCC with the DAX? No. VCC for this chip is probably generated by this U8. That's got a short across it. Fuck. Let's actually see, what is that? What is U... Is that U6, U8? Qu'est-ce que c'est? That is a 662K. That is a 662K. Right there. So let's just see what voltage regulator that is. It's going to be a 3.3 probably. 662K regulator. There we go. Another Chinese special. Yeah, 3.3, I guessed correctly. 200 milliamp. Yeah, so 3.3 volt reg. So either the reg is dead or the chip is dead. I don't know if we'll find a data sheet anywhere, but we can just pull the reg for a sec and see if the short goes away. probably isn't going to go away. It's probably the chip that's got the short in it. Pull the rag. Yeah, I don't think we're going to bother repairing this. I'm mostly just doing this for entertainment. Short's still there. Is it the cap? Probably not. It's probably the chip. It's probably this. But let's just lift the cap just for fun anyway, just to see. I could inject some voltage and see what gets hot, but I might as well just lift the cap seeing as it's here. Oh, I don't have the soldering iron turned on. Silly. Silly! It's a me, entertainment purposes. What do we think then, guys? Is it the cap or is it going to be the chip? It's probably going to be the chip. There we go. I think it's the chip. Or something that's using this supply voltage. It's the chip. Yeah, if I go around the chip, so many pins are connected to this. Also, this chip down here. Also, wherever this is. Let's just start removing things and see when the short goes away. Where's my hammer? Yeah, exactly. Bye, Luna, if you haven't already gone. Enjoy your sleep. Chip is off. Short is gone. So chip was dead. Okay, chip is dead. What is this chip? This AK7735. AK7735 EO. AK7735 E. Oh, it's EQ. That is the DSP chip itself, ladies and gentlemen. Yep, that's the DSP itself. That is dead. 192 kilohertz. Eight in, 8 out. Max clock speed, 147 megahertz. Obviously it wants a 3.3 volts, we already know that. Now would it need programming? I don't know. Maybe. I don't really know with these things. I suspect it won't need programming. I suspect that the chip with the firmware in it that talks to the software is probably maybe in here? AT32F41. Let's do that one. I don't know obviously whether this one's dead or not. AT32F41 5CB T7. Yeah, this is a microcontroller, so this one is going to be the one that is a problem if it's dead. Because this one's going to be programmed, yeah. So this is going to be the problem if that's dead, because we can't program that. I mean, chances are it's probably dead. How can we test? Maybe we can test to see whether that's dead by plugging the USB in, because I don't know. Oh, that's interesting. Now the microcontroller doesn't seem to share the same auxiliary voltage supply as the DSP. It doesn't. So where does the microcontroller get its supply from? Uh-oh. Uh-oh. We have a capacitor here. That's probably on VCC for this chip. And that's got a short. Oh, guys, this is a waste of time. This is a waste of time. Was there a data sheet for that? Yeah, there was. Let's just have a quick look. Which pin is the supply voltage? Come on, show me a pin out. Here we go. Pin 64, VDD. Pin 1, VBAT. I've got VDD as well on 32. VSS. I think VSS is ground, usually. So, does it have a table that tells you? That's a 64, that's a 48. Which is this? Is this... Well, either way, VDD is always on the corner. VDD, yeah, it doesn't. So the ones that are near pin 1 and opposite side of pin 1. So 47 and 48 shouldn't be shorted, and neither should 23, 24. Well, we've got a short there. That's going to be VDD VSS, isn't it? You know it is. Yep. Yep. There's going to be dead. But I mean, of course it's going to be dead. This thing has no reverse polarity protection, and these chips are designed to work with 3.3 volts VCC, and they got 12 volts up them backwards. So of course they're going to be dead. Ain't no doubt about it. Yep, the shorts are gone on the caps. We got more shorts up here. What's that? What's that for? We've got shorts on all these caps, so whatever this is probably dead. I'll tell you what isn't dead. This LED. This LED isn't dead. Woohoo! Yay, free LED. I don't even know what this is. Well, these all still have shorts on them. But yeah, I think it's safe to say that this isn't going to be repaired unless they want to send over all these chips, and I can find all of these short areas that are shorted. Oh. Probably these amp chips may be shorted as well, who knows? Does this have like a power supply section, or is it just using 12 volts as the rail for the amplifier? Might just be using might just be using 12 volts as the rail. I don't see any transformer or anything like that, so yeah, it's probably just using 12 volts as the supply for the rail. I think we had a separate ground over here, didn't we, for the amplifier ground? That was over here. So if I just probe that one, ground. Oh yes. Ground there. Ground there. Now those grounds are the same. So it's a common ground. And whatever is in line with these fuses is shorted to ground through a 3 ohm resistance. So that's probably the amp chip that's dead as well. So yeah, interesting stream tonight, gents. Fun times. This will be a no fix, but we got a couple of other things repaired earlier on in the stream, so that's good. I hope you enjoyed the journey. I hope you had fun on your Friday night watching me buzz around with the multimeter and the scope. It was interesting chatting about potential new video ideas and series, etc. So I'll do some homework, see what I can make happen. But yeah, plan to do some more streams soon, over the weekend perhaps. What does my schedule look like? What does my schedule look like? This weekend, yeah, you might get a stream this weekend. Probably not anything next week. But yeah, guys, hope you enjoyed. Have a great weekend. Catch you sometime soon. See you later.